Guys, welcome back to another set. So in this video we're going to go through the entirety of every single question, and of course to begin with we're going to start with question 1. So let's go. So Nina weighed a random sample of 50 carrots, so N is 50, from her shop and recorded the weight in grams to the nearest gram. So the results are summarized below. So one thing to know about this histogram, because this is a histogram because we got continuous data and whatnot. Now, one thing to note is that if you notice the gaps between 54 and 55, 59 and 60 and so on, there's like entire interval gaps, like one value difference. So to negate this effect, we must always do some sort of correction. That is, look at the midpoint between both of these values and say 54.5 and so on and backwards. How do we know this? Is because Nina actually recorded the weight to the nearest gram, so she's actually rounded down from some error interval. So there was probably an upper and lower bound. This is the upper and lower bound, and there we go. Now let's look at each of the question, yeah? So A, and I'm going to do step by step, okay? So use linear interpolation to estimate the median weight of these carrots. Now to find the median weight, we need to firstly realize that we had 50 carrots, and the median is the middle weight, so the halfway mark, so 50 over 2, so it'll be the 25th carrot. Now to find the 25th carrot, my tip is to firstly always look at the frequency and do the cumulative frequency in brackets next to it. And you'll notice that the 25th carrot has to be between 15 and 37. So I did this nice little diagram here. I put the median on the top and 25 at the bottom, indicating this is the median weight and the 25th carrot. And now put some intervals here. I say 25 is located between the 15th carrot and the 37th carrot. And as for the weights, is located again between the 59.5th weight and 64.5th weight. So again, if you put 15 here, make sure you put 59.5 above it. If you put 37 here, make sure you put 64.5 above it. So here we go. That's it. So this is how you should demonstrate it. Now to actually solve it, what I do is that I treat this like a ratio. So I always write, okay, so let's do M subtract 64.5 over its proportion, which is 25 and 37. So I always match them up, and I make an equal sign. I do another relationship. So I chose in this case 59.5 with 64.5, and of course is corresponding one 15 and 37. So they must be corresponding. You could do other values, but you have to follow the direction of movement for both of them. And then you just solve for M, and that's it, 61.8. Now for the next one, part B. So find an estimate for the mean weight of these carrots. Now to find the mean weight, the first thing you want to do is firstly work out what fx is, because they only gave us the sum of fx squared, which is useful for part C. So to get fx is just frequency times x, which is 5 times 49.5, and you do each one. And then you find the sum of it, and when you add all these up, you get the sum of fx, which is 3085. Now to calculate the mean, it's just simply the sum of that over n, which is 50. Putting this in the calculator, you get 61.7. Perfect. Now, for part C, we need to find the standard deviation of these weights of these carrots. And to do that, I usually find the variance first, because the reason why is because you could just simply square root the variance to get the answer, and that will give you the standard deviation. Now, the variance formula is as follows. It's actually the sum of fx squared, so it's going to be the value in the bracket over n, which is 50, so we have everything, minus the mean squared, so minus 61.7 squared. And when you resolve that, you get an answer, and then you just square root, and voila, 5.93. So these two are quite straightforward, they're just formula based. Now here comes literally the main part. So let's look at part D. Okay, so a carrot is selected at random from Nina's shop. Estimate the probability that the weight of this carrot is more than 70 grams. Okay, now you gotta be very diligent here. Okay, so what I did here is that I looked at the very last interval, because that's where the 70 grams lie, and I firstly just drew this as a rectangle across. So I just kind of visualized it. I treated the width as a class width, the weight, and then the height is the frequency density. Now drawing the rectangle, I just cut down 70 in the middle, and I realized this is the interval we want, the area of interest. Now to work this all out, we know firstly a couple things. We know that the width between here is 10, so I put 10. Now to work out the height, if we know that the total area between here is 13, because frequency is the area, we can just say 13 divided by the width, which is 10, will give us the height, 1.3. And that's it. Now you just use baseline's height to find the area of the shaded part. So between 70 and 74.5, that's a width of 4.5, height 1.3, multiply them and you get 5.85. And that's it. And because the question wants the probability, it's going to be 5.85 over the total number of outcomes, 50. So it'll be 0.117. And that's it. That's literally number 1 wrapped up. And if you guys enjoyed it, please give me a like. Otherwise, let's keep going. So number 2, let's do this thing. So the box plot shows the times t-minutes it takes a group of office workers to travel to work. So as usual, I just literally stuffed everything here, all my solutions, but we're going to walk through it. Now, looking at every single details here, the first thing you want to know is that you got this box plot. The lowest value is the minimum and here is the maximum. Technically, because we have an outlier, the maximum is really over here, 61. Now, and of course, this line here is the low quartile and this is the upper quartile, with this one bang in the center being the median. Now, what's the questions ask? So, A, find the range of the times. So the range would be the highest absolute value, which is 61, which is a little marker over here, minus the lowest possible value, which is over here, 20, which gives you 41. So this one is quite okay. Now, B, find the interquartile range of these times. So this is the difference between the upper quartile, which is over here, the edge of the box, the massive box of 37, and the low quartile, which is 25. And this should give you 12. So quite easy. Now C, using the quartiles, okay, describe the skewness of the data. Give a reason. Now to describe skewness, you just have to look at the shape and ask yourself, how close is the median to the lower and upper quartile? So what I did here is I just found the change or the difference between the lower quartile to the median, which is over here, which was 6, 31 take away 25, and the change between the median and the upper quartile, so the right side, which was 6. Now, if you get the same result, it is symmetrical. Otherwise, if the upper quartile was greater than the lower quartile, it will be rightly skewed, and otherwise, if it was the other direction, it will be negatively skewed. But yeah, we'll get to that when we get to that. So this is simply no skew. Okay, next one. Now, here we go. So we still got D, E, and F. So let's have a look at what Chetna believes. So she believes that the house prices will be higher if the time to travel to work is shorter. I just highlighted, so we should just quickly spot that if one goes up, other goes down. This is a negative correlation. Okay, they're inversely related. Now, she asks a random sample of these office workers for their house prices in pounds, where X is measured in thousands, and obtains the following statistics. So we got the usual stats. Now, calculate the R value between X and T, the correlation value. So between X and T, here is the standard formula. R equals SXT over the usual SXX and STT. Since we got all the values, just smash it in and you realize you have a correlation which is so small, practically 0. Now, state giving a reason whether or not your correlation supports Chetna's belief. So Chetna's belief is a negative correlation. This is 0. The answer is no. So correlation is very close to 0. Hence, R equals 0.004 does not support the belief that house price goes up as time travel to work is shorter. In fact, there is no correlation, so there is no pattern. That's how it is. Now, here comes the last bit, yeah? So Adam and Betty are part of the group of office workers and they have both moved house. Adam's time to travel to work changes from 32 minutes to 36 minutes. Okay, so for this part, this part was a bit confusing because you just need to realize that we're trying to modify the box plot, but not really. Not in a great sense. Now, Betty's time to travel to work changes from 38 minutes to 58 minutes. Okay, so that's a significant change. That's 20 minutes ahead. So that could practically be an outlier, which it is. We'll get to that. Now, according to this statement, outliers are defined as values that are more than 1.5 times the interquartile range above the upper quartile. In maths terms, this means outlier is simply 1.5 times IQR. We can calculate IQR from the previous problem. 37 take away 25 is the difference between the quartiles. Plus, and again, above the upper quartile, plus the upper quartile. So if you just do the quick maths, plug in 12 here, and plug in 37 because upper quartile is 37, you get 55. So essentially, just looking at base time, we can see that 58 minutes is above 55. So this means it's an outlier. Now, anyway, let's look at the question. So showing all necessary calculations, determine how the box plot of times to travel to work will change. Then draw a new one. So Adam's one. So let's look at Adam's rate. So Adam got 36. Now 36 is actually between 31 and 37. So actually it's between these ones. So it doesn't really affect it. So it's actually within the bulk of the distribution. However, Betty's value is an outlier as 58 is bigger than 55. So it'll be somewhere on this side. Now I went ahead and drew this here. So I got something like that. So actually I lied. I copied and pasted from the first one and just stuck an X there. Because why? Because all the values should be the same. And yeah, that's really it. You just plug in X there and you're done. Now we have 2 outliers. Yeah, so that's number 2 done, guys. Now let's move on to the next one. So 3. Okay, so I did this in various steps. So at a school athletics day, the distances in meters achieved by students in the long jump are modeled by the normal distribution with mean 3.3, so that's mu, and standard deviation 0.6, that's sigma. So of course, straight away, just draw your, at least write down your distribution. X is normally distributed with the following usual way of writing it. Okay, A. Find an estimate for the proportion of students who jump less than 2.5. So what this means is that we just want to simply find the value of X less than 2.5 and find that probability. So standard procedure. Now to solve this, we need to convert it to the Z form so we can use the tables. So it'd be Z less than 2.5 minus the mean over standard deviation. Evaluate that, you get minus 1.33. Now because the table is in less than form, this is perfect. However, there is no negative values in the table. So what you should do is firstly take out the minus sign outside and put 1 minus. This is if you want, you can learn this trick. This is a shortcut to how to quickly go from here to here. If you got negative, just whip it out and write 1 minus and then copy the same form. Now, thankfully, if you use the normal table, you just scan for 1.33. I suppose we could quickly scan for that. Okay, here we go. So here's the tables. So quickly scan for 1.33 for the Z value. So remember, you can only use this, the big table, if the probability is actually less than or equal. So this only works for that because we only care about the left hand side of the distribution. So find 1.33, guys, which is over here. So that's how I got 0.9082. Now back to the question. So replace this with 0.9082, 1 minus it, and done. The probability that proportion jump less than 2.5 is this. Now next one. So here we go. So it says here that the long jump competition consists of 2 jumps. Okay, so we're still moving forward. All the students can take part in the first jump, and 40% who jump the greatest distance in their first jump qualify for jump 2. So basically, in the first jump, if you get the top 40%, you will do the second jump. So what I did is I just drew a nice bell curve, did the mean 3.3 because it's always like this, and on the right hand side I just put the value D, represent the minimum value you need to be in the top 40%. Okay, so the reason why it's like this is because in the middle is 50%, so all of this covers 50, so 40 must be on the right, and that's the area of interest. So D is bigger than 3.3, by the way. Now question part B. So find an estimate for the minimum distance achieved in the first jump in order to qualify for the second jump. So that's the D. So all this necessary means is just find use this relationship. So find probability X bigger than D, and we know that the area of that is 40%. And now we just need to expand this to the Z form. So change this to Z. D minus the mean over sigma, the usual form, which equals 40%. And now all we do is just look at the table to find the equivalent value here. Now, one thing to note, for this kind of questions, yeah, you have 2 tables. You have the less than and the greater one. If you're using the greater sign, then you need to use the small table, the percentage table. So let's have a look, and we need to find the 40% mark. So this one records the greatest left, the less than one, whereas this small table records the greater and equal. So something like that, some percentage value. Because we have 40%, we look at P equals 40%, 0.40. And that's equivalent to a Z value of 2.533. Now plug in that in, 2.533. Now all we do is say, okay, this entire quantity must equal this value. So now we just solve this, so times it by 0.6 plus 3.3, and we should get a D value of 3.452. If this is not clear, let me know in the comments if you want me to actually show you an equation with this. Otherwise, let's keep going. Okay, part C. So this is similar. So find an estimate for the median distance in the first jump by those who qualify for the second jump. Now, so this one's a bit weird. So what this means that to find the median distance achieved in the first jump, we need to find basically the median from the top 40%. So literally, you got your 40% value here, we slice in the middle. So looking at this in a bigger perspective, this was the answer for part B. So this was the minimum required to be in the top 40%. Now, if you split this in the middle, you have an area of 20 and 20%. So essentially, we could do two things. We could just, since we're at the edge of the tail, we could just say the probability that x is greater than m must be 20%. And that's what I did. You could also have done probability x is less than m, which would actually qualify for 20 plus the rest of this. And all of that combines to make 80. So you could choose this one or 80%. Anyway, let's keep going. So as usual, convert to the z form. So z now becomes m minus the mean over sigma. And then look for the 20% mark. Since it's greater, we can use the small table again. Alright, so let's see. Okay, p is 20%. This means the z value would be 0.8416. So again, this is the value used to replace the inside part of the probability, yeah? Because when you place that 0.8416, that will give us a total probability answer of 20%. Okay, so yep, replace this with 0.8416. Now equate these two and then simply solve for m. So now we just again times it by 0.6 plus 3.3 and voila, m is 3.80. Okay, so again, so just let me know in the comment section if it's clear, and if not, for future videos I will do an extra step if you want me to. If I'm going too fast, also let me know, because these ones are very intricate and it's good to if you're really following, guys. Yeah, anyway, hey, let's move on. All right, so here we go. So this is the D part now. Okay, so the distance of the second jump is independent of the distance of the first jump. Okay, so this means that we're having some sort of independence rule. So in other words, of course, to get into this, to be the top 40%, we need to at least have been in the top 40% first. Okay, and is modeled with the same normal distribution. So we got the same normal distribution here. Students who jump a distance greater than 4.1 in their second jump receive a certificate. So to make this clear, you need to do two things. So to get a certificate, you need to firstly be in the top 40% in the first one, and then have a probability greater than 4.1. So this is the objective. In the diagram, it looks a bit like this. Yeah. So this is the 40% of winners in this group, of this group. Okay, let's do this. So at the start of the long jump competition, a student selected at random. Find the probability that this student will receive a certificate. So to receive a certificate, we need this quantity. So let's firstly do probability x greater than 4.1. Now, as usual, convert to the z form. So we got 4.1 minus the mean over sigma. Okay, standard procedure, guys. Plug this in a calculator and get 1.33. Now, we've seen this quite a lot. We had this already in the previous answer. So 1.33 was 0.9082. Now, just to be careful here, this is z greater than 1.33. The table doesn't recognize that, so that's why I did 1 minus the less than form, because the less than form we have, and table recognizes that as 0.9082, the big table I'm talking about. And yeah, just doing that, we get the same answer. So actually, this is the same answer as here, isn't it? Yeah, we got the same result here, actually. That's cool. Now, then we're done. So now we found 0.0918. Now we just find 40% of that and done. That is the percentage of people who actually receive a certificate, 3.67%. So far, so good. I mean, if you guys are enjoying it, please just give me a big like, and otherwise, stay tuned for the next one. So, number 4. Right, let's have a look at this one. So I'm doing this. So this one's done over many slides, yeah. So we're gonna take our time here. So the partially complete tree diagram where P and Q are probabilities gives information about Andrew's journey to work each day. So I've gone ahead and filled this out, and I'll explain the yellow part I did later. So this probability tree was P. This means that because these two add up to 1, this must be 1 minus P. Likewise, this was done as 0.4, so this was 1 minus 0.4, so 0.6. These three add up to 1, so we got Q and 0.15. So what I did here, I just did 1 minus 0.15 minus q, and then this reduces to this value, 0.85 minus q. So standard stuff. Now here's the questions. So given that the probability of getting to b is 0.26, find the value p. Now to get to b, we just have to find every single root that ends up in b. So that's why I highlighted these trees. So this is to get to b. So to get to b, we can just do p times 0.4 and 1 minus p times 0.15. So I did that here. So we could say that this probability 0.26 is equal to 0.4p plus 0.15 times 1 minus p. Yeah. Now you just have to expand the bracket, solve, and make p the subject. And eventually you should get 0.044. Easy stuff, I think. Now let's look at the next question. So here's the answer. Now, given also that the probability of not r given w equals 0.175. So this is a straight up given that question. Find the value of q. Right. So first things first, we need to deduce what is the area of w. So for every given that question, the second part of the term is always at the bottom. This is the area of interest, okay? So to get the area of interest w, we need to look back and firstly see all the roots to get to w. So to get w is here and here. So we're going to follow this chain over here. You'll probably notice that I've also updated the p-values over here, so that's good. So now what this means is that because the area is w, this is going to be the underneath part. The bottom part is always the total area because now the entire distribution is shrunk. So we no longer need b or bc. So these are literally out of the probability system. Now in this part, we need to find the not r bit of w. So if you look at both chains, we put both of them down, and to get the not r bit, this is the not r root. So we actually put 56 and q down. So that would be the top half. So one way the best way to memorize this is to firstly put down all your combinations, label it. So this is the r root and not r root, and they want to find the not r root. So you just take the second part and put on the top. So it's always a selection of one of the terms or multiple terms. Okay, that's good. And then when you solve that, you make it equal to 0.175. And now this is kind of a long algebra. You just end up solving for q, and then you get 0.1. So that's fine. That's fine. Okay, so where are we? Okay, next one, part C. Find the probability that Andrew cycles to work. Now, cycles to work, according to this system, is that in the letter that represents it is C, because C represents the event Andrew cycles to work. So we just have to get to C. To get to C is just 56 times 85 minus Q. And you put that over there, you know the value of Q, you should get 42%. Easy. Alright, cool. So let's move on to D. So, almost done, guys. Almost done. So given that Andrew did not cycle to work on Friday, so again, this is another given that question. Since we knew that the probability of going to work, cycling to work is 0.42, that means not cycling to work is 1 minus 0.42. So that is the area now of interest. Another thing to note is that you could have done that, or you could have just done it the long way. Since cycling is here, not cycle to work is all of these routes that are mapped out. Okay, now, so that's the area. So our answer is gonna be somewhere from here. So find the probability that it was raining on Friday. Okay, so raining is R. So we can see from these branches that this is not raining and raining. So we're gonna ignore these ones. So probability of raining could be any route here. So we have to combine. So it'll be probability of raining, either he walked or he biked. So it's gonna be literally every route from R. And you just plug in the top line, put in your calculator, and you should get 22 over 29, or a simplified probability. And yeah, that's it, guys. That's literally number 4 done. Hope this helps, and let me know what you think. Otherwise, as usual, let's go to the next one. Oh, I just want to stretch a bit. Okay, number 5. So Thomas is studying the relationship between temperature and hours of sunshine in CPROM. He records the midday temperature T Celsius degrees and the hours of sunshine S for random sample of 9 days. So N is 9, yeah? He calculated the following statistics. So he's got the sum of S, S squared and T, and he's also got, I cannot read my own handwriting. I think that's STT. Okay? Calculate SSS. Alright, so this is standard formulas. So this is the sum of S squared minus sum of S all squared, so 15 squared over 9. Plug this in and you should get 19.22. Okay, next one. So Thomas calculated the product moment correlation coefficient between S and T and found out that the value was this. So this is the R value between S and T being 0.832. Okay. Now state, giving a reason whether or not this correlation coefficient supports the use of a linear regression model. Now before I even read the rest of this, if your R value is close to 1, or if it's negative, if it's close to -1, if you can get a negative or positive correlation, then the answer would be yes, it supports a linear model. Because a linear model, all it simply means that we want to make a line of best fit between our data points. If we can do that, then it supports a linear regression model. Okay. And then yeah, so to describe the relationship between midday temperature and hours of sunshine. So I just wrote yes, the R value is close to 1, so we can assume a linear model to represent a positive correlation between midday temperature and hours of sunshine. I would probably check the masking for any additional information on this, but I think that should be okay. Now C, state, giving a reason why the hours of sunshine would be the explanatory variable. So in this case, it's usually explanatory variable is always the X term. It's always the X value in the Y equals A plus BX model. It's always the value that for one variable to depend on another. Okay, between midday and sunshine. So what this means is that S is the explanatory variable, so instead of X we can put S there, so it'll be A plus BS must equal T. Reason why we say this is because the hours of sunshine, the midday temperature always depends on the number of hours of sunshine and not the other way around. That's kind of why they suggest it. If you didn't know, you would always just say because T depends on S or Y depends on X. This is just the standard way, but always the temperature in this case will have to depend on how the hours of sunshine are moving. Okay. Anyway, I hope that helps. Let's move to part D. If you need more explanation, just let me know, and then I'll try to do my best to leave a comment on that. Okay. Yeah. So 5. So now on part D and E. So we're gonna do D and E here. So find ST. Okay. So same thing applies. Oh, actually, for this one we couldn't use the general formula. Reason why is because we don't have all the necessary variables. We don't have the sum of ST. So what I did here to calculate this, I just used the relationship between the correlation value R with the general between S and T. So SST over the general formula. Then I just substitute all my values I knew. We have SSS, we plug it there. We have STT from the previous question, which I did not put down, but it's here. And we have the correlation from part B. So yeah, 0.832. So we plug it over there. Then you just make SST the subject and you should get 12.04. Okay. Okay, so let's see. Alright, so that's done. Now calculate a suitable linear regression equation to model the relationship between midday temperature T and hours of sunshine S. So we're using the equation from the earlier parts. Now this is just standard procedure. We just need to find the values of A and B. So A is the mean of T minus B times the mean of S, whereas B would be the S between ST, so SST over SSS. So just if you're unsure what to use, when it comes to the second part, the below part, just recall that the second half must always be the explanatory part. So it's always the X one. So because X is basically S, just put that down. Now divide these two with the values you know, you get 0.626. T bar and S bar is just the mean of T. So the mean of T is 100, is the sum of T over N, which is here, and S bar is the sum of S over N, which is there. And then you just use it with your B value from here, and you should get A equals 13.1. And then plug into your equation. Try to keep the 3 significant figures, yeah? Oh, this is coming off the page, isn't it? Alright, so let me just go back a bit. Yeah, so that's how it should look like. Okay, let's move on to the next one. Okay. Now, so F, calculate the standard deviation of S. Okay, let's have a think. So the way I did this, I just used the standard deviation formula. So since we knew we had the sum of S squared and we have a sum of S, just you write down the general formula, which is the sum of S squared over N minus the mean squared, which is sum of S over N. And then you square root. Just do the simple maths over here, plug it in, you should get 1.46. Easy mark. Now here comes the last two. So Thomas uses this model to estimate the midday temperature in Cypron for a single day in October with 5 hours of sunshine. So 5 hours mean that the S value is now 5. State the value of Thomas' estimate. So this is just simply when S is 5, you plug into the equation here. So 13.1 plus 0.626 times 5, you should get 16.23 degrees. Okay, done. That's it. Now here's the last bit. So, So given that the values of S are all within 2 standard deviations of the mean, so in this context, within is always a plus minus interval. That's what it actually means. Comment given a reason on the reliability on this estimate. So this one's a bit weird. This seems like we're delving off statistics, but we're actually still here. So to write this, think of this carefully. So when it says within 2 standard deviations, this means plus minus 2 standard deviations, literally, of the mean. So it'd be S bar plus minus that. Now, all you have to do is simply put down the mean of S, which we know, which is sum of S over an N, plus minus 2 times standard deviation. Plug this in and then do your interval. So firstly, do the negative value to get minus 1.25 and then do the positive to get 4.59. When you get this is literally just telling you all values of hours of sunshine that it could be between. Of course, you can't have a negative, so it'll be between 0 and 4.59. And now, how can we actually relate this to this question? Well, previously it said Thomas uses 5 hours of sunshine. Since 5 is not in this interval, it's outside the interval actually, then therefore this estimate is not reliable because we're only basing models of hours of sunshine between this. Anything above, we have to extrapolate, which is another method. If it's inside, then we can estimate it. And yeah, that's really it. So hopefully all that stats talks is helping out. Otherwise, let's move on to the final question. Whew, man, I'm getting beat now. So stay with me, guys. They're almost done. Now let's do 6. So a biased coin has probability 0.4 of showing a head. So let's keep that in mind. In an experiment, the coin is spun until a head appears. If a head has not appeared after 4 spins, the coin is not spun again. So this is something to keep note here. So we're trying to see the number of times we get a head. Well, the time we get a head, then we'll stop. So the random variable x represents the number of times the coin is spun. So it can only be spun up to 4 times, okay? So we're going to have only 4 values of x. For example, x equals 3 means if the first 2 spins do not show a head, but the first spin shows a head. So what this means is that you have to keep spinning until your head is shown. So what I did here, I did like a chain of possible outcomes. So for example, if you spun a coin and you got head already, you're done. You don't spin anymore. So it just be probability of head, which is 0.4. If you spun a coin twice, and the first one was tails and then the second one's head, you stop there. So that'll be 2 spins and then there'll be 0.6 times 0.4 probability. And you keep on going. So the idea is that you should always get head at the end, at least for the first 4. Now, since you can only spin it 4 times, there's also a possibility you could just get all tails and no heads. So this is all the outcomes. And that's it. So this all explains the results here. So for example, again, the probability of 1 is 0.4 because it's just 1 head. To get x equals 2, so 2 variables, it'll be 0.6 times 0.4. And then same for 3. For 4, however, it'll be the sum. It'll be, because you have 2 ways of doing it. You can get 3 tails and a head on the 4th, or 4 tails and stop. And and you just sum up these probabilities. Another way you could do this is just work out these 3 and then 1 minus. Anyway, so this pretty much solves part A and B. So let's move on to C and D now. So C, find the expected value x. So the expected value is just simply this. It's just you just pick the value of x times against probability. So it'd be the product between these 2 and these 2 and these 2, and you sum them up. It's very standard. So 1 times 0.4 plus 2 times 0.24 and so on. Should get 2.2 or 2.176. Now, variance x. So the variance x here is defined as the following, yeah? It's the second moment minus the mean squared. So similar to the previous questions, the second moment is simply, instead of having just the expected value x, this is the expected value of x squared. So we need to find an x squared here. So what I usually do, I just replace these x's here with 1 squared, 2 squared, 3 squared, and 4 squared, and then do the expected value. So it should be 1 squared times 0.4, like I did here, plus 2 squared times 0.24, and so on, until you get to the 4 squared times that. So resolve it, and then you should get 6.112. And finally, just plug into the general formula. So it'll be 6.112 minus the mean squared minus 2.176 squared, and you should get 1.38 variance. Oh man, explaining maths is exhausting sometimes. Now, keep it. So guys, let's move on to E. So this is the final set. So once you do this, seriously, pack up your pens and call it a day. So I'll just put some key info. I put the heads and tails probabilities here. We'll explain the rest of this in a sec. Okay. So the random variable h represents the number of heads obtained when the coin is spun in experiment. So explain why h can only take the values 0 and 1 and find the probability distribution of h. So this is quite clear. If you remember from the previous experiment, the whole point of this is that we're going to keep on flipping the coin until we land a head. So essentially you can only get one head. But there was also the possibility that when you get 4 tails, you get no heads. So that's why you get 0 heads or 1 head. Because you can only play until you get head, or after 4 spins you don't. So that's kind of what I wrote here. Now as for the distribution, to get 0 and 1, to get 0, as I just said, we need to get 4 tails. So just find the probability of 4 tails, which we did here, which is 0.6 times 0.6, 0.6, 0.6. And you should get this result here, 0.1296. So to get 1 is just simply, well, 1 minus that, because there's only 2 options. Yeah, that's easy. Now, F. Write down the value of this. Okay, so what does this mean? Probability x when x is 3 intersecting when h is 0. So this is telling us when x is 3, this means you get head on the third option. It's trying to say is that what is the intersection is when you get head at oh my God, I can't even say it right. When you get head at 3 or no heads. If you get no heads, then this statement doesn't make sense, because to get no heads you must have spun it 4 times and got no heads, but you actually got head already, so this is a false statement. It's mutually exclusive, so it'll be 0. Now as for this one, this is possible because if you spun it 4 times, you may possibly get head on the 4th spin, or you don't. This is asking for the time when you don't get head, and when you don't get head, this is the 4 tails assumption. So it will be the result of 4 tails, so 0.1296. So that's quite okay. Now, finally, the last bit. So the random variable s equals x plus h. So just a quick recap, I put the x distribution here. Now, x plus h, to get s just means we're adding up these values here, like 1, 2, 3, 4 with 0 and 1. Now, here we go. Find the probability distribution s. Okay, so this one is, we need to take our time here. So let's look at this. Let's start with h, 0 and 1. So let's assume when head is 1. So if we were to get 1 head, yeah, this means our x values would have probably been 1, 2, 3, or 4. Why? It's because to get 1 head, if we spin it once and x is 1, it means we got a head. So it'll be 1 plus 1. So it'll be 2. This means the probability of that happening is 0.4. Okay, so that's quite okay. When x is, so if your x is 2, this means you got head on the second run. So of course you got the head, h is also 1, so it'll be 2 plus 1 is 3. And the probability of that happening when x is 2 is 24, so that also goes there. Now 4 and 5 is a bit more complicated, because to get s equals 4, there's 2 options. You could either, get x equals 3, get head on the third, plus, and so that means you got h is 1, so that makes 4. Or you could do 4 spins and get 4 tails, and that way you got 0 heads. So x equals 4 and h equals 0 also gives 4. Now what I just did, I just worked out the probabilities. So when x is 3, we know when we get head on the third run, we know the probability of that happening is 0.144. However, for the fourth one, for this to occur, no heads, this means you must have got 4 tails. As usual, this result would be here, 0.1296. So therefore, to get s equals 4 is one of these, so we add them up, and that gave us 0.2736. And finally, to finish this up, instead of me calculating 5, which you can by the way, it's just when x is 4, when you get head on the 4th option, that means h is 1, so you get 5. You could do that, or you could just add all these up, 1 minus it to get that. And that's what I did. Anyway guys, I hope this video helped, and please leave me a comment, and anything else you want to talk to me or give me any feedback for future videos like this. And otherwise, good luck with your exams, and I shall see you next time. Ciao.